Hi, today we're going to look at angles of polygons. So first, before we can get into the angles of polygons, we have to remind ourselves what a polygon is and look at diagonals. So remember, a polygon is a closed figure. Closed figure with no curves, no curved edges, and no intersecting lines that cross over each other. So in a polygon, two vertices or two corners are the endpoints of the same side, then they're called consecutive vertices. So when we talk about a diagonal of a polygon, we are going to take a segment that joins two non-consecutive vertices. So if I pick any vertice, any vertex, any corner on my polygon, so like right there, for example, if I want to draw in a diagonal, I can't go to a consecutive one. I can't go across this line to this one, and I can't go across this line to that one. I have to draw in a whole new piece. So one diagonal on here from that vertex that I highlighted, blue, is going to be like that, if my line goes all the way out to the edge. Okay, so that's one diagonal. From that same vertex, I can draw another diagonal to another non-consecutive vertice. So right there. And on this one, I can actually draw one more. I can go from that blue dot down to this bottom one. Okay, so from any given vertex on this polygon here, I could draw in three diagonals. It doesn't matter which one I choose. If I go back and I undo these, I could have picked any of these spots to start in. So if I pick there, I can still draw in diagonals up to there, over to the far left point, and down to the bottom. Okay, so I'm still having three diagonals. Now the piece that gets this into the angles of polygons is when I draw in these diagonals from any one vertex of the polygon, any corner. What this does, it breaks our polygon into different triangles. So on this one we have 1, 2, 3, 4 different triangles. So on here, then, we already know that every triangle, the angles in a triangle have to add up to 180 degrees. So in this case, if I have this polygon and I cut it into 4 different triangles, really it's like I have 4 times 180, or 500, 720 degrees. So if I took my original polygon here and I wanted to know what are the measures of all of these angles added together, it's going to equal 720 degrees. And I could really also name this polygon. If I named this polygon that I started with, it had 1, 2, 3, 4, 5, 6 sides. So 6 sides. So it's really a hexagon. Okay, so we're going to look and see if we can see some kind of a pattern with this. So here we have 2 more polygons. This one's got 4 sides. and this one over here has 5 sides. Now if we remember, we had talked about different polygons, and we said that if it has 5 sides, it's a pentagon. I'm going to scoot that over. 5 sides, pentagon. And if it has 4 sides, we call it a quadrilateral, using that prefix of quad, meaning 4. So again, if I go through and I put in a diagonal for these, I can then see how many triangles does this make, and I can find the sum of all of the angles of the quadrilateral. So if I pick any vertex, any corner, and I draw in my diagonals, this one I can only get the one diagonal in there. So this one's going to give me 2 triangles, and 2 triangles would be like 2 times 180, which is 360 degrees. So the angles of a 4-sided figure, a quadrilateral, should always equal 360 when you add them together. And that would go for any quadrilateral. It doesn't just have to be this one. Okay. Then in a pentagon, again, I start by drawing in those diagonals. From that same point I started at, go to another diagonal. There we go. That one's not non-consecutive, and neither is this one. Those would be consecutive vertices, so that's all I can do. And here I've got 3 triangles. So that means I'm going 3 times 180, and that equals 540 degrees. Whoa. 540 degrees. Okay. So, like I said, we might have started to notice there's some kind of a pattern here, depending on how many sides our polygon has. When it had 5 sides, we could get 3 triangles. When we had 4 sides, it gave us 2 triangles. And if we look back, when we had 6 sides, I had 4 triangles. So we can use a little equation for this instead of having to do the work every single time. That equation is going to be this. So the sum of the measures of the interior angles of a convex n-gon, so whatever shape it is, however many sides, n sides, our pattern, our rule is going to be n minus 2, where n is the number of sides, and then times 180. So like we did before, when there are 6 sides, when n is 6, I'm going to go, well, 6 minus 2 times 180. And this gives us 4 times 180, which gives us 720 degrees. Now really this piece right here, that is finding how many triangles are in this figure. If I take the number of sides minus 2, that will always tell me how many triangles this would have if I drew in all the diagonals from one corner. Okay, so let's try one problem like this. I want to find the sum of the measures of the interior angles of this figure. So if I measured all of these little angles, how big is that going to be? Well, first we want to start with how many sides does this have? We have 1 side, 2 sides, 3, 4, 5, 6, 7, 8 sides. And really, I don't want to show that they're congruent. I just know that there's 8 of them. So 8 is my n. So I want n minus 2 times 180. 8 minus 2 times 180. Well, that's going to be 6 times 180. And if I take 6 times 180, it gives me 1080 degrees. So if I measured all of these little angles in here, all 8 of these angles, it should add up to those 8 angles, 1080 degrees. Okay? So hopefully this video will help you find the angles or the angle measure for the interior angles of any given polygon that we come across. Thanks.